Hi friends, welcome to KMAT GATE Education. This is the question from network theory. So in the question he asked that equivalent inductance between A and B. Equivalent inductance between A and B. So this is A and this is B. From this I want to find the L equivalent. Okay, so we know very well about the impedance, that impedance equal to ratio of voltage to current. So if I find the ratio of the voltage to current, I will get the Z. So Z equal to R plus J XL. So I will get R equivalent and XL equivalent. From that I can find the L equivalent. This is the procedure to solve the problem. Okay, the ratio of the voltage to current is an impedance. So for that purpose, what I do here is simply I place a voltage source here and I take current I. If I find the ratio of the voltage to current, I will get the Z equivalent. From that I can find R equivalent plus L equivalent, or directly I will get L equivalent. So whatever may be, let's see. Okay, so first of all apply loop here. So whatever the voltage here, this will be the here plus or minus V. Okay, the same voltage appear across this dependent current source. Dependent current source. So apply KVL. Minus V plus Vx plus Vy plus 4Vy equal to 0. V equal to Vx plus Vy plus 4Vy. So you can clearly observe here Vy equal to 2Vx. You can see here the plus minus symbol and the plus minus symbol is same. The voltage, the Vy equal, the polarities are same. Okay, the polarities of the is same. Okay, so Vy equal to 2Vx. Okay, and you substitute here Vx plus Vy how much? 2Vx plus 4 into 2Vx. So 3Vx plus 8Vx, that equal to 11Vx. 11Vx. And you clearly observe Vx, this is the Vx. Vx equal to L into di by dt. So what is the voltage Vx? Vx equal to L into di by dt. What is the current? You can see here. You see here. This is current Iz is coming here. So this Iz here, this Iz here, this Iz here, this Iz here. Okay. So here Iz current in this circuit, in this branch. Okay, in this branch Iz is flowing. Okay, so in this branch Iz is flowing. You can see here I is entering, here 0.5Z is entering, here Iz is leaving. Apply KCL here. If you apply KCL here, I current entering, 0.5 Iz is entering and Iz is leaving. Iz is leaving. So what is the current here? I equal to 1 minus 0.5 Iz. Okay, so Vx equal to L into di by dt. You see here Vx equal to L into d. What is the current here? Iz by dt. Diz by dt. Okay, and Vx equal to how much? Vx equal to L into diz by dt. So you substitute here V equal to 11 into L into 11 Vx, where Vx equal to, substitute here. Substitute Vx equal to here. So 11 into L into diz by dt. Diz by dt. Okay, and you can clearly observe 11 into 4 millihenry, where Iz equal to, here from this equation, Iz equal to I by 0.5. So you can see here d by dt of what is Iz? I by 0.5. So 11 into 4 millihenry 0.5 into di by dt. So V equal to something L equivalent into di by dt. I get the equation. What is this L equivalent? Is the answer. So 11 into 4 into 10 power minus 3. Okay, so 5 into 10. So you take 10. Okay, so 44 into 10 by 5. So something 440 by 5. 5 8s 40. 5 8s 40. 5 8s 40. So 88 millihenry. 88 millihenry is the answer. How much is the L equivalent? 88 millihenry. What is the L equivalent between AB? So this is the procedure to solve this question. Let's see the next question. Let's see the next question here. Determine the current I1 for this circuit. Determine the current I1 for this circuit. From this you can say this 16 kilo ohms represent this branch, this resistance, 6.4 kilo ohms represent this resistance, and this 8 kilo ohms represent this resistance. Okay, the meaning of that, they are placing on the top. Okay, from this, here this 12 volts is applying, is in parallel to these two branches. This is one branch, this is second branch, this is third branch. Okay, this 12 volts is same for this branch and this branch. So here this node voltage is 12 volts and this node voltage is 12 volts. So you can solve in any method. Let's see. Okay, you can see here unknown parameter you have Vx. Here also, if I know this, then I can easily solve this question. Okay, so for that purpose you can see here this Vx is given here, this Vx is given here. Okay, you can apply voltage division principle. So here 16 kilo ohms is there, here 8 kilo ohms is there. You can apply the 12 volts is apply across this branch. I can apply voltage division principle, that Vx equal to 12 into 8 kilo ohm by 16 kilo ohm plus 8 kilo ohm, that equal to 12 into 8 divided by 24, 8 3s, so 4 volts. So Vx equal to 4 volts. Vx equal to 4 volts. Okay, now you can find Vx in another way also, no problem. You can see here, let current here Ix, let current Iy here. So what is the voltage here? This 12 volt is applying to this total branch. What is the current Ix? So the current Ix equal to 12 by 18, 16 plus 8, 24 kilo ohms. Ix equal to 12 volts by 24 kilo ohms, that equal to 1 by 2 kilo ohm, that equal to half milliampere. So what is Vx here? Half milliampere into 8 kilo ohms, that equal to 4 volts. 4 volts. So indirectly you get Ix equal to 0.5 milliampere. So current through this branch is 0.5 milliamperes. Okay, so if I know current through this branch, then the matter is over. So you can see here 12 volts is there, here 4 Vx is there. What is the Vx here? Vx equal to 4 volts, that equal to 4 4 16 volts. Okay, so 12 minus 16. So the current is in this branch, you can see here, in this branch in this branch you can see here the current is, this is 16 volts, this is 16, 4 into 4 16 volts. Here you have 12 volts. Okay, 16 minus 12 is 4 by 6.4 kilo ohms, 4 by 6.4 kilo ohms. So current is going like this, current is going like this. How much is 4 by 64 kilo ohms? 4 into 10, okay, 64 milli. So 1664, okay, so 10 by 16 milliamperes in this branch current entering. So apply KCL at this node, so current is entering I1 and here current is leaving. How much it is leaving? 0.5. current is leaving 0.5 milliamperes, 0.5 current is leaving, and here 10 by 16 milliamperes in this branch current is entering. So 10 by 16 milliamperes. So I1 equal to 0.5 milliampere minus 10 by 16 milliamperes. 10 by 16. Here you can observe that this is a dependent current source. You can observe that 0.6 milli S into Vx. What is S here? Siemens, millisiemens, okay, into Vx. What is Siemens? Means conductance unit. Conductance unit is mho. So inverse of mho is ohm. So voltage per ohm is current. So indirectly he is giving that 0.6 milliamperes. 0.6 milliamperes. So 0.6 millisiemens into Vx. Okay, this Vx here it is there. Okay, so here unknown is Vx. If I found this Vx, then I get the answer. Okay, then I get the V1 very easily. Let's see here. Here 0.6 millisiemen into Vx is going, that is current is leaving. Here current is entering. Let current is leaving here. Current is leaving here. So the V1 is this branch voltage, this V1 is this branch voltage, this V1 is this branch, because these three branches are in parallel. So if you apply KCL at this node, so let 4 milliampere is entering. You can see here 4 milliampere is entering, and let Ix is the current leaving here. So 4 milliamperes is entering, Ix is leaving, and 0.6 millisiemen into Vx. Okay, I can write this as Ix as V1 by 4 kilo ohms plus 2 kilo ohms, 6 kilo ohms plus 0.6 millisiemen into Vx. So I can write this as 1 by 6 V1 millisiemens. So I am taking kilo to above. Kilo goes to above, what happens? Milli. Ohm goes to above, what happens? Siemen. So 0.6 millisiemen Vx. Okay, so here 4 milliamperes. So I want find V1. Okay, so here unknown variable is Vx. What is unknown variable here? Vx. Two unknown variables are there. If I found this Vx in terms of V1, then I get the answer V1 is very easily. Okay, let's do here. Let's see here. This is a parallel branch. Total voltage is V1 and I want to find Vx. Let apply voltage division rule. If I apply voltage division rule, Vx equal to V1 into 2 kilo ohm by 2 plus 4 6 kilo ohm. So Vx equal to V1 by 3 volts. Vx equal to V1 by 3 volts. If I substitute here, let what happens, see, 4 milliamperes 1 by 6 V1 millisiemens plus 0.6 millisiemens into V1 by 3. Okay, so simply I will take V1 millisiemens common, okay, V1 millisiemens common, 1 by 6 plus 6 by 10 into 1 by 3. So 3 2s, 2 5s. Okay, so V1 millisiemens into 1 by 6, 3 2s, 2 5s, you get 1 by 5. Okay, so this is, you take LCM, 6 5s 30, 6 5s 5 6, 11 by 30, right. So if you solve this, 4 milliamperes V1 millisiemens into 11 by 30, milli cancel, okay, milli cancel, V1 equal to 4 amperes into 30 by 11 Siemens. Okay, so this Siemens, if I go to above, this is ohm, ampere into ohm, V equal to I into R, voltage. So this unit becomes voltage. So 4 into 30 by 11 is V1. So if you solve this, you get 10.9, approximately 10.90 volts. 10.90 volts. So V1 is 10.90. So hope you understand. So if at all you have a dependent source, first to solve whatever the possibility is there, first to solve that unknown variable, then you solve for whatever he given in the question, Okay, let's see next question.